Hello everyone and welcome to the 7th video in solving systems of equations. Here we're going to step it up a notch and work on a 3-variable system using elimination. Now if you're not comfortable with elimination on a 2-variable system, I suggest you go back and watch the last 2 videos and do some practice problems because it's going to be really difficult to do this if you're not already comfortable with a 2-variable system. So I'm not going to go over the basics with this because, again, that you should check out in the other videos. Here we're just going to see what's different between the 2 and 3 variable system and go forth and solve this. So, same situation, I'm going to need to pick a variable to eliminate. When I eliminate the variable, I'm going to do that by adding 2 of the equations together. What's different here is I have 3 choices for the variable to eliminate, x, y, or z, and instead of just adding the 2 equations, I'm still going to add 2 at a time, but I'm going to have to do this twice. One of the equations I'll use twice. So here I'll use the blue equation 2 times. One of the times I'll add it to the red equation, and the other time I'll add it to the green equation to eliminate a variable. Now I have to use one equation twice, but the other equations I can only use one time. And whatever variable I choose to eliminate here, whether it be x, y, or z, I'm going to have to make sure I eliminate that same variable in both equations. Looking at this, the way I have my equation set up, I think it'd be easiest to eliminate the y variable. If I eliminate y, I think it'll be easier than the other ones because if you notice here, the y's are already opposites of each other. So I don't have to multiply either equation by anything. But over here, uh, I'll only have to multiply the red equation by -5 to make them opposite. So I think that's the best scenario to go with. I could multiply or eliminate any of the 3 variables. I just think y would be the easiest here. So let's go ahead and do that. Now I'm going to have to eliminate the same variable twice. So here I'm going to eliminate y. Oh, got away from me there. I'm going to have to multiply this bottom equation by -5 to get the y's to be opposites of each other. I don't need to multiply the top equation by anything, and that's perfectly fine. So I can go ahead and copy this one to use again, but then the red one, I'll write it in, having multiplied it by -5. -2 times -5 is 10x. -5 times y is -5y. -5 times 4z is -20z, and -5 times -9 is 45. Okay, now I have my 2 equations set up where the y's are opposites of each other, so I can go ahead and add them together to eliminate the y. So -6x plus 10x is 4x. The y's are going to eliminate and turn to 0. I'm not going to write the 0 in. I'm just going to skip over the y term now that it's gone. And then 2z plus -20z is -18z equals, and -11 plus 45 is 34. So that's my first equation. Now I'm going to go over to the second set of equations on the right here, and I have to eliminate the same variable. If I eliminated y on the left, I have to eliminate y on the right. If I don't, then I will not be able to solve this problem without doing something different. All right, so I'm going to add these two together. -6x plus 4x is -2x. 5y plus -5y cancels and disappears. I'm just going to get rid of that term completely. And then 2z and 5z is 7z, and -11 and plus -4 is -15. So now I have my 2 equations. Right? I need 2 equations because I still have 2 variables left. While I did eliminate the y, I'm still left with a z and an x. And as we learned before, in order to get rid of 2 variables, you're going to need 2 equations. So basically, I took this 3-variable system and I turned it down to a 2-variable system. Now, once it's a 2-variable system, I'm going to solve it just like I did with the regular 2-variable systems. It's going to be the same process. I need to eliminate a variable. Once I eliminate the variable, I can then solve for the other variable and then start plugging things in. Now, looking at this, I think it'd be a lot easier to solve for or eliminate x than it would be to eliminate z, just because we have a 4x on top and a negative 2x on the bottom. What I really have to do here is just multiply the bottom equation by a positive 2, and then that will give me opposites of each other. So I'm going to copy the top equation down. The bottom equation gets multiplied by a positive 2, so 2 times negative 2 is negative 4. 2 times 7z is 14z, and 2 times negative 15 is 30. I'll go ahead and go back and make this orange. And now what I want to do is add these two equations together now that the the x's are opposites of each other. So 4x plus negative 4x is 0. They're going to disappear. I don't need to write it. Negative 18 plus 14 is negative 4z. And 34 plus negative 30 is 4. And now I have one equation, one variable. So let's take a look at what happened here. Here we started with our 3 equations and 3 variables, and I added the blue one and the red one to eliminate the y, and I got an equation that was x and z. And then I took the blue one again, combined that with the green one to eliminate the y again, and left with another equation that's x and z. Once I have 2 equations with x and z, I can go ahead and solve that like a 2-variable system, eliminating the x, and now I have an equation with just z. So I can solve for z in this equation. Negative 4z equals 4, so I am going to divide both sides by negative 4. So I have 1z, and I'm left with z equals negative 1. Now what I want to do is I want to take one of the 2 variable equations, whether it be the purple one or the orange one, and plug in z and solve for x. I'll use the orange just because the numbers are a little smaller. Alright, so I have this equation. I can go ahead and plug my z in that I just found. So that gives me negative 2x plus 7 times z, which is negative 1, equals negative 15. And I'm going to go ahead and simplify down and solve for x. So I can do 7 times negative 1, which is negative 7. So negative 2y minus 7 equals negative 15. And then I can add the 7 on both sides. That gives me negative 2x equals negative 8. And then I could divide both sides by negative 2. And that gives me x equals 4. Okay? All right, so I had my 2-variable system. I solved for z. I took that z, plugged it into one of the equations, solved for x. So far, let's sum up what we have. We have x equals 4 and z equals negative 1. I'm still missing y. So what I'm going to have to do is go back up to one of the 3 original equations. Doesn't really matter which one. Pick your favorite one here. It looks like 2, or the red one. The second one has probably the smallest numbers to deal with. It's really up to you. Whatever one looks the best to you. So I'm going to take that equation, and now I can solve for y by plugging in the values of x that I found. So I have negative 2 times x, which we found to be 4, plus y, which we don't know yet, plus 4 times z, which is negative 1, equals negative 9. So now I have this equation with just y. So I can go ahead and solve for y in this equation. I can do negative 2 times 4 to give me negative 8 plus y. And I can also do 4 times negative 1 to give me negative 4 equals negative 9. Now I can also combine like terms, negative 8 minus 4. Remember, when combining like terms, to include the sign to the left. So that's a negative 8 minus 4, which is negative 12 plus y equals negative 9. I can then add the 12 on both sides, and that gives me y equals 3. And now I have my 3 answers. You're going to want to write this as an ordered triple, as x, comma, y, comma, z. So x is 4, y is 3, z is -1. If you wanted to, you can go ahead and check this by plugging it into all three equations for x, y, and z, and make sure that it works out on all three of them.